I am the director of cepar, which is one of the founding organizations of the International Pension Research Association, which is the institution hosting tonight's very exciting webinar. In Australia, we always have an acknowledgement of country, and I would like to do that now. So let me begin. I'd like to acknowledge the traditional owners and custodians of country throughout Australia and their continuing connection to land, waters, and culture. I pay my respects to the elders, past and present, and extend that respect to Aboriginal and Torres Strait Islands who are present here today. And since this is a virtual event, I'd encourage other Australians around the country to acknowledge the people of the lands you are in, if you know them, by entering that in the chat function. I'm currently on Gadigal land. So before I begin and turn the podium over to Mike Orsak, who will chair this evening's event, let me just give you a few ground rules and say a few words by way of introduction to the Pension Research Association. The ground rules are up on your screens now. If you're not speaking, please turn your microphone to mute. Submit any questions or comments to the chat, and Mike Orsak will adjudicate those, and the presentation will commence very shortly. It remains for me to introduce IPRA, to just say a few words about IPRA. IPRA is an organization that was set up by a number of founding institutions that were very concerned about getting some kind of global organization to focus on pensions research. It's been going for a couple of years now. Hazel Bateman, who is with us tonight, is its current president. You can find out more about it on the website. This just gives you an idea of our fees. Now it's my pleasure to introduce Mike Orsak, who is also one of the founding members of IPRA. Mike is head of research at Willis Towers Watson, a founding member, as I said, of IPRA. He joined a precursor of Willis Towers Watson Wyatt in 2001 and has been head of research one way or another ever since. He's a founding editor of the Journal of Pension Economics and Finance, and he's done many things to promote international research into pensions around the world in the time since. He's got a PhD from the University of Michigan and graduated initially from Princeton. With that, I will turn the podium over to Mike. I will stop sharing and wish you well for a very stimulating webinar.
Thank you, John. It's my pleasure to introduce James Poterba, who just about everyone on this call probably knows because he's been working on pensions and annuities in particular for decades. James Poterba is the professor of economics at MIT, president of the National Bureau of Economic Research, and a trustee of TIAA-CREF. It's my pleasure to have a chance to chair this session. Please, everyone, as Jim is going to talk for about 35 minutes, please share questions. We're only going to 15 minutes for the question and answer session. I'm going to try to organize the questions into broad thematic areas. Jim?
Great. Thank you very much. It's a great pleasure to be with you all today and to see many old friends on this call, including one of my very first collaborators on annuity issues, Olivia Mitchell, and to be able to share some recent work by other researchers and by me that bears on a question of annuitization and the drawdown of defined contribution plan balances. I should say as I begin that I, in addition to my academic role at MIT and my role at the NBER, I am also a trustee at TIAA-CREF on the CREF account, and none of what I share with you today will be representing the views of TIAA or CREF or Nuveen in any way as we do this. So let me try to begin by sharing screen and explaining that basically my plan for today is to walk through a combination of two distinct papers so that I'll be able to give you some sense of work that has focused on understanding the way in which individuals in defined contribution plans make choices when confronted with annuity options, and also sharing a little bit of evidence on the valuation of annuities that we see in the marketplace at the moment. So the motivation for all of this, at least in the United States, is that there is growing interest in annuitizing DC plan assets. And that is seen both in regulatory policy, where we are seeing the Department of Labor requiring plan sponsors starting in 2019 to provide illustrations of what kind of annuity income flows participants would be able to secure with their balances. We've also seen the Secure Act, the same legislation, beginning to provide safe harbors for plan sponsors who might offer in-plan annuities, and trying to resolve a long-standing problem that plan sponsors have faced, which is annuities are very long-lived products. If you sign up your participants for an annuity contract and something goes bad a decade or 2 decades down the road, the concern in the litigious United States is that will expose you to future lawsuits. And many plan sponsors, I think, have been reluctant to go down that path. We are also beginning to see in the US market novel innovations that are trying to deliver lifetime income solutions. Some of you here in North America may have seen just last week that BlackRock, for example, has instituted a partnership with Bright House and with Equitable Holdings that will be offering in-plan annuities to a number of new plan sponsors. So things are happening on this front, and it shines the spotlight a bit on what's the workings of the annuity market, which has attracted much more attention in the research community than it has, to be honest, in the sort of at least the individual financial market in the United States. So what I'd like to do with you today is to basically do 2 things. First, I'm going to share a little bit of evidence on the changing patterns of income draw and annuity demand amongst TIAA participants. This is work with Jeff Brown and Dave Richardson, who I know are well known to this group. And this is a paper which just summarizes a mature defined contribution plan, which has had an annuity option from the get-go, and illustrates, I think, some of the issues around the factors that seem to be impinging upon annuity demand at the moment. And then I'm going to talk about one of the favorite topics of at least the economists who study the annuity market, which is whether or not the limited demand for annuities is somehow reflective of just high costs in this marketplace, that the actuarial value of these products is not all that high. And this is joint work with Adam Solomon, who I must tell you is a graduate of UNSW, now studying for his PhD at MIT. And we'll be looking at the individual annuity market at the US, as well as on the deferred annuity market, which is a new and exciting development that Olivia and Ray Maurer and various others have been studying recently. So let me start by just saying a little bit, and we can certainly come back for questions on this, about the TIAA administrative data that Jeff Brown and Dave Richardson and I look at. TIAA is the second largest annuity provider in the US after Social Security, with about 1.75 million participants who were over the age of 55 in the last decade. And essentially, these are all participants who have access to an annuity within their retirement system. So the question of what are they choosing to do is not one of limited access, it's rather where we're learning something about the choices that they make. And of this group at the moment, right, about one in 6 is currently receiving an annuity payout. And we think of that as meaning, the rest of the group in some senses is kind of at risk of being able to take an annuity if they were to choose to do so. So what I'll just show you is the historical time series, and this was originally begun by John Amerix, now at Vanguard, of the fraction of participants in TIAA who, when they begin to draw income out of the system, do so in the form of a life annuity. Right? If you go back to 1988, there wasn't much anything else they could do. So these numbers are nearly 100%. And you see in the course of this graph, a number of alternative payout options that did not involve annuitization were introduced. And therefore, over time, the fraction choosing annuities begins to drop down. By around the year 2000, that fraction was about 50%. And what you can see is that in an environment which largely has involved the same choice set since 2000, the fraction choosing to take an annuity as their first draw has fallen from about 50% to around 20% in the most recent period. Okay, so one of the challenges is to understand what's happening as this trend has played out. and to understand potentially what the heterogeneity is in terms of who's choosing, who's not choosing, and how we might understand the dynamics of these choices. And that's the goal of the research program that Jeff and Dave and I have been carrying out. But I want to just show you the evolution of annuities and then the alternatives to annuities over time. Now, this is a very busy looking picture, and I'm going to call your attention to really just two pieces of this. The bottom bars in this graph, the dark blue and then the lightish green, the ones which in 2000 are 29% and 33%, correspond to single and joint life annuities chosen. And this is essentially when we see someone who was a participant in this system beginning to draw income, what kind of income are they drawing? Okay. At the very top of the 2000 graph, you see the aquamarine bar, which is people who are taking required minimum distributions. In the US system, as I think many of you are familiar, if someone reaches historically the age of 70 and a half, now the age of 72, without having taken any distributions from their defined contribution plan account, if they are no longer working, in most cases, they will have to begin taking distributions at that age. These are called required minimum distributions. And what you can see is that in 2000, about 10% of the initial income draws took the form of required minimum distributions. That part of the graph expands over time as the annuity part at the bottom declines, so that you can see by 2018, the last year in our sample, only about 18% of the first draws are taking the form of annuities, and more than half of those first draws are now taking the form of required minimum distributions. So essentially, these are forced distributions where the participants in these DC accounts are now running up against legislative requirements that they begin taking money out of their accounts. I want to show you a simple split of the data, looking at people who are under the age of 70 and over the age of 70 at the time when they begin taking their distributions. Okay, this is the under age 70 group. And if you look back in 2000, okay, you'll see that 67% of the group was taking an annuity, and the RMDs don't apply to people under the age of 70, so they're not even on this chart. And there is a decline in annuitization during the early 2000s, but you see that it's roughly stable by the time we get to around 2007, 2008. And even today, close to 40% of this group, the under 70 first income draw population, is taking an annuity payout. Contrast that with what's happened to the group that's over 70. It was much higher in terms of the RMD fraction, even back in 2000. And today it is overwhelmingly coming from the RMD side. And so what you're seeing as you just look at these two charts is which age category people are in is going to be highly correlated with whether they choose an annuity or not when they begin drawing income. So one thing that could contribute to the pattern that I showed you at the beginning is, well, if the income mix, if the age distribution mix has been changing over time, that could indeed be quite consequential for what we see. And in fact, within the sample, these are mostly academics and support staff at universities who are participating in the TIAA system. Over the last 2 decades, we have seen a gradual increase in the retirement age for both men and women on average, moving up by about 2 years for men, a little bit less than that for women. And the result is that the population has actually shifted toward an older group in terms of those who are able to take income draws within the TIAA system. So whereas in 2000, only about 14% of the group was over 70, in the most recent years, close to 2/3 are in that category. The workforce has become more female over time. The longevity in the system is pretty similar. And the other thing that's changed a lot, and we will call attention to this in terms of what's driving things, is the interest rate that prevails, in the nominal interest rate that prevails has, of course, declined quite substantially. And that means, and I'll say more about this in a moment, that the available payout that one could expect from annuitizing a given pool of resources has declined over time. Some of that just reflects the decline in real interest rates. Some of that has reflected a push down of expected inflation. And understanding how that affects the behavioral choices of the participants, I think, is one of the key issues, and something that has been studied and we tee up as an important issue going forward in this. We do think that there's certainly the potential that the significant decline in nominal interest rates has led to less enthusiasm for the annuity option over time. What we do find, and I will not draw you into the cross-sectional results at this point, is that there are large disparities across different individuals in the system with different characteristics. in the likelihood that they take income as an annuity. For example, if you have a $100,000 balance for a 67-year-old with 25 years of work in the TIAA system, they have about a 50% chance of annuitizing. Someone with a smaller balance who's 71 years old, short service, much lower in terms of the likelihood that they will take an annuity when they begin taking draws. So, what's the role of interest rates here is one question, and the other question which this tees up is, how close, not just for TIAA, but much more generally for the demand for annuities, how close to actuarially fair are the annuities that are available for those who are operating in the marketplace. And before I shift to the annuity section, I should just observe, and this is something that Jeff and Dave and I believe is potentially quite an important effect here. If we think that some part of the retiree population is keying off the stream of income that they are drawing from their accumulation and trying to use that as a guide to their consumption planning or other important real side decisions, the choice between a required minimum distribution payout strategy and annuity is quite important. Let me just show you. This is a chart that just shows the real value of a required minimum distribution payout, starting with $100,000 at age 70 and beginning the distributions at age 70 in the US. And of course, if you're taking out an amount which is a fraction of, a pre-specified fraction given your age, which is the way these RMD tables work, the rate of return that you're earning on the assets that are in the DC account are going to be very important for the time profile. So I've just shown you here a 2, a 4, and an optimistic 6% real return on this portfolio. And what you see is that, with a 2% real return between the ages of 70 and 100, you are pretty flat in terms of the real value of the payout you're taking over time. With a 4% real return, you're actually increasing in terms of the real value of the payouts, because the rate of return on the DC account is outpacing the rate at which the RMDs are drawing funds out of the corpus of that account. At 6%, you're actually increasing much more rapidly. Now, of course, remember with the RMD structure, there's a balance left in the account whenever someone dies. So that's a very important difference. And note the level on this chart, which is that the payouts begin at a level for $100,000 of accumulation at a little bit less than $4,000 a year in terms of the payouts that would take place. Contrast that with an annuity purchase. If you purchased a nominal single premium immediate annuity for a man at age 70, did that in June of this year, the light blue, which is the declining line here, shows you the real value of just picking a nominal annuity. I've assumed a 2% inflation rate in doing this calculation. Note that you would start at almost $6,500 in terms of the initial payout. But of course, inflation would erode the value and you would decline. If you instead chose to buy an annuity which offered you 3% escalation per year, you'd start at a much lower level of payout, only $5,000. But of course, with 3% escalation and my assumption of 2% inflation, you'd be rising in terms of the real value of the payout over time. The key is just, when you compare and contrast the level and the slope of these annuitized outcomes with these RMD outcomes, it just, for me, it drives home the point that the way in which people are choosing to draw the assets out of these accounts is potentially consequential for what they are going to think about as their spending patterns in retirement. So let me now kind of pause for a moment. That's looking at the real side of decisions about annuities and trying to link this to the kind of payouts that people will have. I now want to shift gears for just a bit, and in the remainder of my time, talk about the work with Adam Solomon, which is focused on understanding annuity pricing, and also linking up and saying a bit, because I think it will be particularly interesting to some of this audience, on how the Department of Labor is guiding plan sponsors at this point to begin offering information on annuity payouts to their participants. I begin by noting that annuities, frankly, play a greater role in the research space than in the marketplace in some cases. And here I'm thinking about true life contingent annuities, single premium immediate annuities, or their various cognates that are in the marketplace. And we have a large literature that talks about why that market might be small, including that there are pre-existing annuities with Social Security type benefits, precautionary savings motives where you need the liquid assets, bequest motives, and this possibility that annuities might be expensive in some way, either for administrative costs or because those who purchase them are adversely selected relative to population mortality. So let me just kind of give you a sense of what Adam and I do in our research. We study the U.S. retail annuity market very much in the spirit of calculations that Olivia Mitchell and Jeff Brown and Mark Warshawski and I did several decades ago, and that Mark did actually even a decade before we were working together. We are looking at data that was provided in mid-June of this year by the Annuity Shopper magazine in the United States. It's offers of 17 large firms that are providing annuities to the retail marketplace. Want to be clear for my insurance experts on the call that we do not have information on underwriting rules or market volume for these providers. These are just posted quotes, and recognize that as you interpret what we've got. These are the payout numbers that you see in terms of the averages of what's available to a purchaser of an annuity at this point. So a 65-year-old man purchasing a single premium immediate annuity, complete, everything ends when he dies, would in June of 2021 be receiving about $5,800 a year in return for $100,000 payout purchase premium, right? So that's an important number to understand in terms of where we are, and to put that into some perspective. If the same person had been purchasing that annuity back in 2000, the payout would have been almost 10%. If they'd been buying that annuity in 2010, the payout would have been about 7.5%. So, what's been happening as interest rates have come down is these payout numbers have been declining, and that links back to the question of is part of what's happened to the demand for annuities this declining nominal payout number that is causing people to be reluctant to annuitize. If you look across the rows here for a 65-year-old woman, the payout number would be slightly lower, reflecting, of course, differentials in longevity. And if either the man or the woman were to choose a 20-year certain policy, they would be finding a smaller payout, of course, reflecting the fact that the chance the insurance provider would have to pay out for longer than with a single premium immediate annuity. We in the research paper, which I cite in the references, we look at other annuity products in the marketplace, including, for example, refund annuities, which are at this point very popular, and escalating annuities. But for the moment, I'll focus primarily on what I think of as the bellwether nominal single premium annuity in this analysis. The essence of our calculation is just going to be to ask the question: if you purchased one of these annuities at the average price I've just described, what is the expected present discounted value of the payouts that would be associated with that? And the question, to answer that question, we will need three pieces of data. We'll need the market data on the annuity payout, which you've just seen. That's A in this expression. We'll need a measure of the probability of surviving to different ages. Okay, and of course, there's lots that can vary in the assumptions one makes about mortality. Particularly because if we're trying to value these purchases in 2021, we need to forecast mortality going forward to understand what the prospects for the annuity purchaser might be. And then we'll need some sort of a discount rate assumption to figure out how to calculate the expected present discounted value. And there, at a time when interest rates have moved dramatically in the last couple of years, and when the risk spread between, say, riskless treasury bonds and riskier interest rates has widened, the choice of which interest rate to use, which discount rate to use, becomes more consequential. I should say, just as a teaser as we think about this, right, I'm going to mostly focus on the challenges of calculating this EPDV measure, but I want to link this up with what the Department of Labor in the United States is suggesting that a plan sponsor do, because for the DOL to give guidance to the plan sponsor on how the sponsor should calculate the potential annuitized stream for a participant, right? That requires an assumption about what is the survival prospects of the participant and what is the discount rate that should be used, or what is the available rate of return that could be assumed for the insurance company that is providing the annuitization stream. And just as I'm going to show you that the EPDV is somewhat sensitive to the assumptions I'm going to make, the flip side of that is that the assumptions that the Department of Labor would suggest that a plan sponsor make will be consequential for the numbers that will come out in terms of the potential annuity lifetime stream for the participants in DC plans. So let me just show you, to give you a sense of the different components here without diving into too much of this. The principal ways in which I will report discounting here will be to use either the Treasury yield curve, and that's the blue curve that I've shown here. Yield is plotted on the vertical axis, and as you see in June of 2021, the short end of the Treasury yield curve was very, very low, with interest rates that were close to zero, moving up to numbers between 2 and 2.5%. Once we get out to maturities of say 15 to 30 years, we have to in some sense impute the end of the yield curve for very long maturities. But fortunately, the calculations are not too sensitive to what's happening there. The green curve is the corporate A-rated bond curve for the U.S. It is higher than the Treasury curve, particularly when we look at the longer dated maturities by something on the order of 50 basis points. And the yellow line, the yellow horizontal line, is the 10-year yield to maturity on a Treasury bond. And I put that on the chart because that is the interest rate that the Department of Labor suggests a plan sponsor use in doing the calculation of potential payouts. And one of the things that's going to matter as we try to understand the DOL, the DOL suggestion here is you can see that this is basically for a long-lived annuity going to be using a lower interest rate, lower discount rate than the market yield curve. But of course, for nearer dated cash flows, the discount rate is going to be substantially higher. You'll see an example in a little bit of how that matters as we look at this. The other component is that we need the survival rates. Okay, we're looking at cohort mortality tables. So these are for people born at a particular age. I'll be focusing on people who are 65 in 2021. And there are two different groups that we will focus on. One is using annuitants, using data from the Society of Actuaries, from their annuitant tables, individual annuitant tables updated with their recommended assumptions about mortality improvement. The other is population data using information from the Social Security Administration. And importantly, SSA and SOA have made different forecasts about the future rate of mortality improvement. SSA is the more pessimistic of the two. SOA, the study that was done principally their 2012 annuity table, drew on data from a very rapid period of mortality improvement in the US between the mid-1990s and about 2010. And extrapolating that forward means that you do end up with a more favorable distribution of future mortalities from the standpoint of the annuity buyer, one that is more expensive to work with if you're doing this from the standpoint of an annuity supplier. Just to give you some sense, these are the data for mortality rates on US men starting at age 65 in 2021. You can see that the population mortality rates, the light blue, are significantly higher at all ages than those from the annuitant population, and the annuitant essentially is the Society of Actuaries. It turns out that the level difference between the annuitants and the population is most of the action here. The final bar, the blue bar, shows what happens if you marry the SSA's assumptions about future mortality improvement to the SOA's initial conditions. You do find something which moves a little bit toward the population table, but not very much. And you can see what this implies in terms of the structure of mortality. This is just the distribution of dates of death for a 65-year-old man, and you can see the SSA table has a peak at an earlier age. The most common age of death is in the late 80s, and much higher probability of dying at various ages in the 70s and early 80s relative to what happens with the SOA table when you do this. So putting these pieces together, what we will end up with is a calculation of the expected present discounted value from the formula I showed you before. This table, this is kind of the core table for the results of the annuity valuations. And it just shows you that, say, I'll focus on the box for men, population and annuitant mortality, and then treasuries versus A-grade corporates as the discount rates. There are significant differences across these four cells within that category. And what you can see is that if you assume that the annuity buyer will have the annuitant mortality risk, and the discount rate is the treasury yield curve, it looks as though the present discounted value of the annuity payouts are actually greater than the purchase price. The expected present discounted value is more than dollar for dollar. On the other hand, the least favorable assumptions for the buyer which is population mortality, and a higher discount rate, the A grade corporate, puts you down to an 83 cent on the dollar expected payout. So, how does one try to judge amongst these different things? The benchmark case that Adam and I focus on in our paper is the annuitant mortality A grade corporate, the entry which I have bolded here, on the grounds that the insurance company portfolios tend to have bond structures which are more like an A grade corporate than treasuries in terms of their risk profile, and the purchasers of annuities at the moment tend to look like the annuitant mortality table, not the population table. And this comes up with an expected present discounted value of something on the order of 95 to 97 cents on the dollar, depending on exactly which age group and which product you happen to be looking at. So we interpret this as suggesting that at this point, the retail annuity market in the U.S. for an annuitant buyer is delivering a payout stream that is not very far from actuarially fair in terms of the kind of calculations that we are doing. Okay, and this has been, to a first approximation, there seems to be some evidence. We've done the calculation for multiple years. When interest rates declined in the late 2010s, the EPDV number seems to have risen somewhat, but for the last 3 years, it's been relatively high. Moshe Malevsky and others have documented that it seems as though annuity payouts seem to adjust sluggishly to the changes in interest rates. As interest rates come down, that means the payouts may be a little high relative to where the equilibrium will be. And that seems to be broadly consistent with what we observe in a chart like this. So this is just the immediate annuity purchases that one can get. Let me now just come to the DOL calculation for a moment and remind you of what it's suggesting that the plan sponsors do. So the DOL basically asks the sponsor to take a mortality table, which the Internal Revenue Service makes available in the US for sponsors of defined contribution, sponsors of DC plans in doing calculations. This is a unisex table that combines men and women, and it assumes no mortality improvement. And that's actually consequential as we look out to the future. They also suggest that the sponsor take the 10-year nominal treasury yield, as I mentioned before, and then they essentially need to solve the following expression, right? Which is to say, in our terms, $100,000 purchase price must be equal to whatever this A, the available payout is, multiplied by the survival probability from this IRS table, discounted by the 10-year treasury. And the question is, what number comes back? Okay, and when you do it, just to look at the intermediate steps here, the DOL's unisex mortality table is if you look at these mortality numbers by age, the annuitant mortality table has a substantially lower force of mortality at all ages for both men and women. The SSA's population table has a substantially higher force of mortality. So these numbers kind of fall in the middle, not the middle, but they fall in between those two, and they are closer to the annuitant table than to the population table, reflecting the fact that the underlying population that is used for this calculation is something close to defined benefit type participants, I believe, at the moment. Okay, where do you come out when you do the DOL calculation today? If I put together the numbers that I've just shown you using the DOL table calculation for a 65-year-old, remember this is any 65-year-old because men and women are treated the same in the DOL calculation. The assumed payout would be about $5,600 from a year from $100,000 balance. How does that compare with what we see in the market for a single premium immediate annuity for these individuals? Well, it's a little bit less than what a man could purchase in the retail market, and a little bit more than what a woman could purchase. Well, that's kind of not all that surprising given what we see, but because it's a unisex table. And notice that it's pretty close. Okay, move out to age 75 and do the same calculation. And what you now see is that the DOL estimate is significantly higher than either the man or the woman's pricing available in this SPIA market. Why is that? It is because of the trade-off between the annuitant versus the DOL table in terms of the annuity table, the mortality risk which is being used to price these. And it's because the effect of the interest rate becomes different as we move to the older ages than to the younger ages, right? Essentially what's happening here is that if you're pricing for a 75-year-old, as you're pricing an annuity in the market today for a private firm, you're thinking that those low numbers in the yield curve are going to be the principal interest rates that affect most of the payouts that apply to an annuity written for a 75-year-old. But in some sense, the DOL estimate is saying, no, start using that 1.5% interest rate right away. So the part of the payout structure, which is affected by the higher versus lower discount rate, is different for an annuity written to a 65 than to a 75-year-old. And that accounts for some of what's going on here. Okay, without belaboring the point, I think the key message here is that making the assumptions that the DOL has prescribed are consequential. Precisely in what direction, you can't say they always overstate, they always understate. It's going to depend. It's going to be a facts and circumstances situation, but it does require looking and figuring out, okay, where the interest rate on the 10-year Treasury falls relative to what a yield curve that you might look at with a full term structure will be. And similarly, the trade-off between the unisex versus the calculation for men or for women. And as you can see in this calculation, the differential at age 75 for a woman is much larger than the differential for a man. What this, of course, would suggest is that if you thought you were keying off the number that the plan sponsor was giving you using the DOL estimates and you were a 75-year-old woman, and you then tried to actually purchase that annuity, you might discover that you couldn't find the annuity at the payout rate that they had suggested. So last thing I want to mention, and then I'm eager to turn to questions. One of the interesting developments in the annuity market in the last few years has been the rise of deferred annuities. Deferred deferred means many things to many people in the insurance marketplace, but I'm thinking here about the kind of policies that Olivia and Ray and others have looked at, which basically say you're buying annuities. It's longevity insurance. Instead of buying a policy that begins paying you an annual stream at 65, you buy at 65, but you actually get the policy to begin at, say, age 85. Okay, and this is intriguing as a way of, in some sense, putting some of the household's assets in a purchase that will provide the kind of insurance against a very long life that might be most valuable. So how do we think about the deferred annuity, or how do we think about a deferred annuity compared with a single premium immediate annuity? If you look at the single premium policies that I've been focusing on up until now, okay, so take the 65-year-old man, discounting at the SOA mortality rates and the corporate A. The EPDV I showed you was around $97,000 for a $100,000 policy. $82,000 of that is due to the payouts up to age 85. Okay, so it's giving you a sense of, okay, about 85% of the value of that policy was coming before you kicked into the part, which was beyond the start date now for the deferred annuity policy that might be available. So effectively, it's giving you a sense of how different the deferred annuity and the immediate annuity are in terms of the part of the life table that is going to be relevant in terms of understanding their payout structure. Okay, if we take the same mortality tables, same interest rates that we talked about before, and we use them to value the deferred annuity payout rates again in June of 2021, somewhat smaller sample of firms offering these deferred annuities at this point, but focus on my 65-year-old man. If he purchases a policy which is going to begin paying at age 85, okay, 20 years of deferral, $100,000 today gets you a policy which will begin paying you $32,000 at the age of 85. Okay, somewhat smaller for women because, of course, they have a higher likelihood of still being alive at age 85. And if I then turn around and do the calculation and say, well, what's the expected present discounted value? The numbers are significantly lower than what we saw in the earlier calculation for the immediate annuities at age 65. So again, this is for 65-year-olds. For men, using my preferred A-graded corporates in the annuitant mortality table, looks like something on the order of 83 cents on the dollar for men and about the same for women. You do see the same patterns of, if you use the Treasury yield curve and the annuitant mortality table, these numbers are much higher. You get very close to 1. But I think the evidence we've seen from before suggests that it's unlikely that the Treasury yield curve is the appropriate discount rate to use in terms of thinking about these numbers. So I think this is we are just at the beginning of trying to understand the way in which these annuities are being priced, and the question of whether there is a greater degree of selection in the market for those who purchase the deferred annuities, and that accounts for this. So a table that is different from the standard SOA table on annuitants, for example, is that the relevant thing to use here? Are there other components here that need to be thought through? Open issue, and very much something that Adam and I would love input on. So, where do we conclude? Money's worth values for these individual annuities, single premium, look like they are, in the upper 90s under reasonable discount and mortality rate assumptions. Lower, of course, if someone's a buyer with population mortality risk. Deferred annuities look significantly lower. And as we look at this DOL calculation, it does seem as though, it's no fault of the DOL. The DOL calculation is sensitive to the assumptions one makes about the inputs to these annuity calculations, just as the EPDV calculations are. But I think we all just want to try to convey a sense of there's some range around these numbers, and it's important to recognize that as we proceed. So with that, Mike, thank you very much for letting me go so long, and I will be happy to take questions as they are.